And so number 7 from the 2016 Advanced Higher Maths. We've got another 6-mark question here, little 2x2 matrix. First of all, for 1 mark, just what's the determinant of this matrix? Well, the determinant of A, a 2x2 matrix, is the product of the main diagonal minus the other diagonal, product of the other diagonal. It's only worth 1 mark, so you could just state it, or you could show it as 2 times -1 minus lambda times 0. So that means the determinant of that is -2. Put that in. And that gets you a mark. Part B then, show that A squared, multiplying the matrix by itself, can be expressed in the form of this. P lots of A plus Q lots of I, and it says stating the values. You have to remember to state the values of P and Q. Well, not that you know it at the school level, that's actually a rearrangement of what's called the characteristic equation of that, and it involves the determinant as well as the sum of the main diagonal, but you don't know any of that, so you just have to go ahead with A squared being the product, so multiply it by itself. Scalar product, horizontal times vertical vectors. 4 plus 0 is 4, 0 plus 0 is 0, 2 lambda minus lambda is lambda, and 0 plus 1 is 1. Doing that gets a mark. So, what is this then? What's this linear combination here? What are P and Q? Well, there'd be a formal technique for that, where you'd equate this matrix to the result of that matrix. Then equate the corresponding elements. However, sometimes it might be possible just to do it by inspection, if it's an easy case. And noticing here, A just has a single lambda, A squared has a single lambda, so it looks very much as if it's just A with something added onto it. So what has been added onto it? Well, 2's been added onto that, and that's 0, and that's been left alone, and 2's been added onto that. So that's equal to then 1 lot of A plus 2 lots of I. In other words, P, the number of A, is 1, and Q, the number of I, is 2. Now doing it that way, forming this would give you a mark, and then stating P and Q gives you the 3rd mark. However, doing it the formal way, which would be longer in this case, would simply be, well, if this is meant to equal that, that means that P lots of A, 2, 0, lambda, -1, plus Q lots of I, 1, 0, 0, 1, should equal A squared. Tidying that up into 2 equal matrices means that you've got 2P plus Q for the first element, and that's a 0. This one's just got P lambda, and the last element's going to be minus P plus Q, I'll just call that Q minus P. Which means then that immediately P equals 1, and since from the first element 2P plus Q equals 4, that means that Q must equal 2. So I'll put that down first. And then, just like the reverse of the previous one, I better state this. So A squared was then A plus 2I. So the 2 marks in this case would be 1 for equating the 2 halves of that equation. And unfortunately, you'd have to have both of these parts, because you had to write it in this form and you had to state P and Q. Now part C, obtain a similar expression for A to the power 4. Well, a similar expression means a linear combination of A's and I's. Well, A to the 4 would be A squared times A squared. So that would be A plus 2I times A plus 2I. A times A, that's A squared. A times 2I, I'll just keep them in order, but of course it makes no difference multiplying by the identity element, identity matrix, whether you pre or post multiply it, but just keep them in order the way you should when you do matrix multiplication. Plus, but of course, a constant can come to the front, plus 2ia plus 4i times I, 4i squared. And of course what that says is a squared multiplying by the identity element leaves it alone, so that means I've got 4 lots of a, and of course that goes back to just I again, so plus 4i. Now, multiplying it by itself, I'm not sure exactly where it comes into this, but there's only 2 marks. It might come in here, but I'm going to put it there. Gives the first mark. The next mark comes from substituting it back into itself. So that a squared reappears as a plus 2i, I'll just emphasise that, plus 4a plus 4i. Giving you finally, a to the 4 is 5 lots of a, plus 6 lots of I. There's the last mark. And it didn't say anything but p's and q's and stating p's and q's here. So there it is then, 6 marks. Oops, forgot